reflection of any graph, not just the parabola, of any graph, not just the parabola. If I want the reflection about the x-axis and the reflection about the y-axis, you've done that in grade 8, grade 10. Okay. If I say reflect something about the y-axis or reflect something about the x-axis, it's a principle. Pay attention. So there's a reflection about the y-axis, then you've got to know wherever your graph was, every point that was on this side is now on this side of the y-axis. Sketching it is a good thing, but if I just say, here's the equation, get the reflection, you don't have time to go and sketch the whole thing and sketch its reflection and then get that equation again. You've got to realize, very important thing, is if it's a reflection about the x-axis, well, I'm on the y-axis at the moment, about the y-axis, then every point, wherever it was, it'll now change to the other side. So what changes? The x value changes its sign. If it was on the negative side, it's now going to be on the positive side. If it was on the positive side, it's now going to be on the negative side of the about the y-axis of x. So you're going to change your x becomes a, that's the rule. That's the reflection about the y-axis rule, but it must make sense to you as I explain it here. About the y-axis, if it's on this side of the y-axis, the x's are negative, then it becomes positive. So whatever happens, your x must change its sign. How do I change it? By timing by a negative. So a minus will become a plus, and a plus will become a minus. For a y, the reflection about the x-axis, what's changing? You see me the practical of this. If this is the x-axis and your graph was there, it's now going to be there. What changes? The y value, if it was plus, is now minus. If it was minus, it's now plus. So you must change your y into a negative. If it was negative, it'll now be plus if you times with a negative. But the rule is, if I say, please get me the reflection about the x-axis, that you change the y into a negative y. And what about the rest? Then I leave it like that. Well, you'll get one mark, but you're not going to get the second mark, because that's not right. It has to be in the correct form. And now remember, you've got another standard form. You've got standard form for parabolas, ax squared plus bx plus c. That's the one that you're used to. Now you've also got this in turning point format. A, x minus p squared plus q. Are you with me? Parabola in turning point. Alright, so if I've done that, is that acceptable? The minus stays there. Nope. Must go away. The other side. It's always y equals mx plus c. Y equals ax squared plus bx plus c. Y equals, not minus y. So you must get this thing written correctly. So I'll time the minus away. How? So just put it in the front there. Which will mean that whole term is timed. And the minus 4. Think about it. So your turning point that used to be 2 and 4 is now going to be does this change the 2? Nope. This just changes the shape. If this was a positive parabola, it's now going to be a negative. Think about it. This used to be your parabola. It's now going to look like that. To make it reflect about the x-axis. So that's what the negative does. It makes the positive a negative frowny face. So that should be. But the turning point, x value, will still be 2. Is that correct? Yes? If it used to be 2, it's still going to be 2 for x. But the y that used to be 4 is going to be negative 4. But that wasn't the question, that's just more explanation of how it works. If you do the sum, you must know that y becomes a negative y. If you don't know that, you're not going to get the mark. Reflection about the x-axis, y is timed with a negative. And then you write it in the correct way. Don't time the time again. This is just saying I had a positive, now I've got a negative. I used to have a positive parabola. This one's now going to be a frowny face negative parabola, and it makes sense. You don't have to sketch it, but it makes more sense if you do. Please don't do an exam, you don't have time. For a reflection about the y-axis, you've got to change your x into a negative x. Do that on this particular example. So y is going to be happiness on that? But that's not quite right. That's not right. This has to be a plus. So what should I do?
Take out a negative.
Can you just do that with a square? Isn't it just easier to time the whole thing out? Remember now, the basic thing is to change it. So you got one more. If you want to write this now and time it out by saying, let's time the two brackets out. Because you can change it by taking out a common minus, that's perfect. But then you've got to do it with both of them. So how many minuses did you take out? And then if it's two of them taken out, it'll just stay positive. And let's think about it. That's way too much writing, but I want you to see what's happening here. If you leave it in turning point format, it used to be a positive parabola. Now we are doing a reflection about the y-axis. If it's a positive parabola and you reflect it about the y-axis, you should still have a positive if it reflects from one to the other side. What's the change? The turning point will be, instead of 2 and 4, negative 2, and still 4, because it's just reflected about the y-axis. So x has changed into a negative. If you had timed the whole thing out and given the answer in a squared plus bx plus c, I wouldn't mark it wrong unless they state it. Leave it also in turning point form. Then I want it in that form as well. Okay, but all of this was way too much writing. I just want the answer. Okay, and then probably they would have said, what is the new function that has developed? What is its turning point? Then you could have answered me, minus 2 and 4. Right, so we're still in our method of all of our graphs. We have 4 graphs, and in each of them we're going to sketch them, and then we're going to find the equation. So we've done the straight line, both of those. We've done the parabola, sketching it. We've done a few things extra now with the reflections. Yesterday we did the, what did we do? Translation, up and down, left and right. Will that happen in any graph? Yep, up, down, left and right. Reflect around the x and y axis. Whether it's a parabola or whether it's an exponential graph, you're still going to have these same 2 rules. Whenever I say about the y-axis, x becomes a minus x. About the x-axis, y becomes a minus y. It's something that appears always, but you don't know at which graph, and always for about 2 or 3 marks. Now, we've done the sketch of the parabola. We need to do the finding of the equation. So, new work again. You know that we're working towards the mixed graphs. And on a mixed graph, like in grade 10, you're going to have a parabola and a straight line and a what and a what and a what. I'm going to ask you where they cut, where's this, where's that. But before we can get to that, also, you have to be able to, on the graph has this and straight line and whatever on it. And I say, please go and find me. Let's call it a name. Did I call it a name then? F. Let's call it a name, because then I can say, find the equation of f. What has been given on that sketch? The y-intercept and the turning point. Very important. And they've got to tell you that you don't have to wonder about it. Turning point. So if you're looking for the turning point, what do you think is your technique or your tool that you're going to be using? Which are the general formulas for a parabola? Now listen to me, you're never going to use that to find the equation. I'm saying that there's two methods. There's actually three, but we don't do the third one anymore. Two methods of finding the equation. And the first one is if I give you the turning point and a point. If I give you the turning point and a point, which formula are you going to use? I just said you can't use that. So you're going to use the formula? The new one that you were taught. But you haven't put it in there yet. You've only just read it and seen, oh, I see the turning point. I can see what the turning point is there. Now we're going to go backwards. So in this graph, and we've called it f, so let's make it fx over there. We know that y is equal to, so we're going to take this turning point and substitute it back in with minus 3. And?
Plus 4.
Okay, if I give it to you like this and you've got to sketch it, you know that you should time the x value with a negative to give it to a plus. If it is plus there, it should be negative. There, are you with me? You're using that same formula but now in reverse. Now, let me ask you the golden question. How many variables do you still need?
2.
One. There's one missing variable, namely? What's the golden rule if one variable? You substitute with a point. Let's do 3, 4. No, you've already used 3, 4. If you do that, can I give you a golden rule? If you do it by mistake, the stress is a terrible thing. You start doing crazy things. If you do go and substitute 3 and 4, it's wrong. And you're going to have 4 equal to a. You're going to have 3 minus 3 there. You're going to have plus 4. What's going to happen here? You got 0. And 0 times a is 0. So what's your answer? You just made a breakthrough in maths. 4 is equal to 4. What were you looking for? And it's missing now. What's wrong? You used the same point twice. That's what's wrong. Because you've already got the 3 and the 4 in there. Now, golden rule, if ever you choose a point and this happens, you're looking for C, you're looking for Q, you're looking for whatever. And what you're looking for is going, poof, gone. Choose another point. You hear the very mathematical reasoning there? If you choose a point and the A or the B or the whatever you were looking for disappears, choose another point. I've explained to you why this happens now, but for all purposes for future reference, if you choose a point and the A or the B or the variable disappears, choose another point. So don't choose the 3 and the 4. See, that's why you've got to have the turning point as well as another point. And another point is then 0 and 2. Excellent, guys. Not 2 and 0. So in the place of x, we have 0. And in the place of y, we have 2. And now we only have one variable to solve. Remember, the x's and the y's are the infinitely many coordinate pairs that sit on your parabola or whichever graph you're busy with. So x and y are not variables. So now we're going to solve quickly. This gives me minus 3 squared is 9. Times a is 9a. I'm already taking the 4 across. It's negative 4, so it becomes negative 2. So that my a is equal to negative 2 over 9. Does that confirm the shape of this parabola? A negative? Okay, it's a little bit of a check for yourself. If it was positive, you made a mistake somewhere. Can't be positive. Has to be negative. Am I done? No, you still have to give me my answer. Find me the equation. And the equation then is y, which was now called f, is equal to, in turning point format, negative 2 over 9, x minus 3 squared, don't forget the square, plus 4, and I'm very happy, and you've got like 5 marks. Finding the equation of a parabola, but it's new work. You need that formula. If I give you the turning point and a point, method number 2 is coming up. Turning point and a point, you've used it already. inside of your previous sums, you know that it's the turning point. And this has all got to go into sync with what you know. If it's negative, it's got to be a negative parabola there as well. All right. And this you can leave in that way. I want you to make a note. You can leave in turning point, format or form. Unless the question said, find the equation of f in the format ax squared plus bx plus c. Does that mean I start there?
No.
Never ever would you start there. But how do I get there? If I got there. Simplify. Time out the square, time out with a negative 2 over 9, add, and it will be ax squared plus bx plus c. And that c should be
2.
Are you with me? Why isn't this a 2?
Because it's not the y.
It's not c. It's q. It's the y value of the turning point. Are you with me?
Yes.
Good. Okay, so what will the question be? Find the equation of h, or the parabola, or whatever. Equation is ax squared plus bx plus c, but we never use that formula. Especially if they ask you, give it to me in the form ax squared plus bx plus c, you don't start there ever. But now I need to teach you a new formula, another new formula. The formula is if you have two x-intercepts and another point, then you're using this formula. How are you going to remember all of this? Lots and lots of practice and study. Alright, so this is a brand new formula. Guess what x1 and x2 are?
X-intercepts.
The two x-intercepts. So you cannot start off with a x minus b squared plus q. Because then I know you're on the wrong path. You can't use the turning point because you don't have the turning point. So you will get one of these two in a test, but not both. You have to realize if it's a turning point, you use the turning point formula. If it's x-intercepts in a point, you use that. So for my sum, and I called it h, so eventually I'm going to write hx. For my sum, I'm first of all going to substitute the x-intercepts. X's, girls or boys? Guess what I'm going to write? Negative 5.
Positive.
These girls. Okay? X-intercepts. What are you short? What do you still need?
A.
You see it being a general thing in all of your graphs? I'm searching for one variable. The moment I'm searching for one variable, I do it by substitution of a point. Which point?
The other point. The
The other one.
y-intercept.
What's going to happen if you substitute minus 1, 0?
It's going to
The
disappear.
A is going to be gone. Then you know you chose the wrong one. Why am I saying two x-intercepts and another point? Because you need another point. You can't use them again. So if you do, please remember what's going to happen. The A will disappear. Then you know. Just take another point. Okay. The other point is then which point?
It's the y-intercept.
The y-intercept that was?
0 or negative 2.
Okay guys, that's just a nice thing to do if you're setting up a test, is to use the y-intercept, but it doesn't have to be. It could be this point that was 6 and 1. I just remember, please, I'm putting any random number there. It's not the answer on this board. Because does 6 and 1 lie on that graph? I don't know. I'll first have to go check. If I want to put another one on there, I must make sure it is actually on there. All of my points adhere to the equation. The equation, whatever it is. So I can't just say 6 and 1 lies on the graph. I've got to actually go and see if it does. So if I substitute with negative 2 in the place of y, and then my x values with 0, then I will find A. Let's see how I do this, because remember order of operations. The brackets give me negative 5 times 1. That gives me negative 5. Are you with me? Negative 5 times 1 is negative 5 times A. Excellent. And now to get A alone, you divide by negative 5, which will give me positive 2 over 5. Smiley face. Confirmation. So I need to go back and say, okay, the equation then is y equal to 2 over 5, x minus 5, x plus 1. And you may never ever leave it in that format. This is just a tool to get to the equation. But you're never allowed to leave it in this format. You have to time it out, so it's going to be in which format? Ax squared plus bx plus c. Whether they say something or not, you must never leave it in the x-intercept format. It's just a tool to get to the equation. Alright? All the learning stuff you've got to know. How would I do that then? Old school. You're going to do the FOIL and then time in the 2 over 5. Please don't ever time in the 2 over 5 first. You were taught that long ago. First do the FOIL. First do the FOIL, and then you're going to time in that 2 over 5. And time it there gives me minus 8 over 5. And if you time there, you get negative 2. Why does that make me happy?
Because there's a y-intercept.
Confirmation of the y-intercept. Now, if I had given you 6 and 1 or whatever, I didn't have confirmation of that. But if there's confirmation, the stuff must fall into place. This has to be the y-intercept of negative 2, otherwise I've made a mistake somewhere along the line. That's the only thing that can happen if I ask you for the equation of a parabola. Now guys, there is a third method where you actually do use ax squared plus bx plus c with substitution and simultaneous equations, but that's not asked in the syllabus anymore, so I'm not even going to go there. Just so that you know, there is something like that. So when I ask you to get the equation of a parabola, you'll have to see which one you're going to use. What did Lamb give you? Did I give you turning points and a point? Or did I give you x-intercepts and a point? And those formulas you must know off by heart, otherwise you're not going to be able to do the sum.